Okay, so good afternoon, guys. Welcome back. We will continue with our Docker session. So today is Docker Day 7 session, and today the date is 26th of your December 2025, and the timing is afternoon 12:05 p.m. IST. So, guys, today would be a very important session because we will be understanding about something about the images today. Okay, before we get into today's topic, let us try to quickly recap what we did on Day 6 session. Okay, so in the last session, we understand about the Docker architecture, right? Whatever the architecture, latest architecture, what we have discussed about that, and I told about this latest architecture, and also I also told you all that like you please concentrate on this architecture because in many interviews they might ask you, and you have to explain the same thing whatever I discussed in this in the Day 6 session actually, all right? And after that, like we have something different modes which we run and execute in a container. One is something like attach mode, and other is not, but something like a Docker which you can make it to run in the background, right? So this is what the modes we had understood, and then we also try to learn some commands actually, like CP command, exec command, like that, right? Like even if you remember, guys, we also discussed something about the export option, like Docker container export. And also, if you remember, you had even discussed about the Docker container import also. So I would be writing in the Day 6 only, guys. This Day 6 only, I'm just writing these two commands. So we had discussed, we had even execute these commands also, right? So basically, what this command does, basically export is, suppose for example, if a running container, you want to share that container to some other person, right? Or if you want to share this running container image to some other person, then you use the export command. Once you export it, basically as a part of the command output, you're going to get some kind of a tarball. So in our case, we use something like web.tar actually. So this is the tar file we created. And when you give the tar file, the other side, the other person who is working on the system, he will try to take this web.tar, and then like he's going to use a Docker container import command to import it, and he's going to import as an image actually. And with the help of that image, what he will do, he will try to run a new container with help of that image. Okay, this is what one of the way where we can achieve by sharing image from right from one machine to other machine, or else from one person to other person actually. So is there any other way where you can do it actually the same thing, guys? So like if you try to copy the same command, and if I try to have in a Day 7 session, so we can do the same thing with the help of a Docker container commit command also. So commit command is quite simple, guys, because we are directly creating an image actually here. So here what happened at first, you are going to export it, and once you export it, you will get a output as a tarball, and then like you import it, the import the web.tar and create an image. So can I create a directly? Can I create an image? Can I create an image or directly from the running image or the running container? Yes, you can create with the help of a Docker container commit command actually, right? Let us see how to do it. So if you go back to your AWS account, I think I already logged in. So there's a Docker server is already a server where the Docker is installed, right? So let me copy, let me copy the public IP of this. Go to your download folders. Okay, and let me log in. Okay. So guys, I already have, right? Basically, if I try to do a Docker info, let's check whether Docker installed or not. So we can check that Docker is installed, right? Let me check if I'm any kind of a container running Docker container ls. Okay, nothing is there. Docker container ls-a. So I think I have already have removed everything. Let me check even Docker image ls. If any images are there, I think no images, guys. I think I cleared it everything in the last session itself, actually. But how we are going to do it actually? Right. It means that I have to first run a container. So let me do thing. Let me first do a container. Docker container run hyphen name something. My web server something. Web server. Okay. And then like what do you do? Like uh, okay, run hyphen it. I will use okay, and then like you have to give some image name, I'll just say Ubuntu 22.04, right? So I'm just running this image actually. So Ubuntu image I'm just running. I've given the name as my web server. Some name I'm given it here. So it has downloaded, guys, and you could see that you have even logged inside the container also. And if you try to have one more duplicate session, and then like try to do a Docker container ls, you could see that your container is running actually, and which has this image 22.04, right? Now, and if you try to do a Docker image ls, you could see that actually the image which you download was 22.04. This is the image you downloaded as part of running this container, right? You execute this command and you could see that you have given this image name with the tag or with the version 22.04, right? And the same thing, what happened, right? You would see that the image is downloaded, right? And it is there in your Docker local system. This image exists. Now, what I'm trying to say here that now suppose if I try to do this is an image which is running. Now you say that Rajesh, I want to create an image out of this running container. Yeah, you can use this command by Docker container export and specify it, and then Docker import. You can do it, but can I do directly? I can do it. Yeah, you can use with the Docker container commit command. So if you try to go here and if you try to do a Docker container -fn help, now you could see that there is an option by name commit here, command option. I create a new image from the container changes. So can I create an image actually? Yes. So what you have to do that you have to just say Docker ps and then say Docker container commit, and then you have to give this container ID or the image name or the container name. I'll give the container ID. So this container ID and give your own image, something like my web image, something. So guys, you could see that a new image has got created. How to check it? If you say Docker image ls, now you could see that actually you got your image actually. You got the new image, my web image colon latest, and you could see that this is the image you created. And this image you can share to anyone actually. You can share it to anyone. You can even copy this image and share to anyone, and you can able to share to the other person. Or even you can run one more container with the same image also. Am I clear, sir? So in this way, you'll be able to create an image. Now, here the thing is that what you're trying to do that from the running container, only, you are actually creating an image actually. Now, whatever your running container is there, assume that here I'm just plainly running my Ubuntu image. That's an operating system image. Assume that you're running something like an Nginx image where already an application is running inside that Nginx image. Now, when you try to do a Docker container commit, so what happened, right? You're actually getting a new image, and that new image also already it also has an application also. It means that this is a kind of a ready image, customized image. You can use it for your requirement. So it means that any container which is running, which already has an application which is running inside the container, then in that case is what happened, right? You will be able to create a new image out of it by using a Docker container commit, and you can use that image anywhere, wherever you want to, wherever you want to use that application, right? You can use that image actually. So this is one of the way to create an image actually. But do you think that we try to create an image or new image with this method? No, because this is something like where you are trying to have a kind of a replica of this actually. It means that if suppose if any container is running, yeah, you can take a image, you can just take an image out of the running container and you can run that with that new image in some other system, you can run it actually. But do you think that actually we build the image with this way? No, we don't build the image with this way. There is a different separate way of creating an image itself, building a new image that we are going to see in all our upcoming session actually. Okay, guys, is it fine?
Yes, Rajesh. Yes.
Okay,
Yes, Rajesh.
good. Now I already told you guys that please have account in a Docker Hub actually. Please have an account, guys. It is very important for all of us. Like if you go here to the hub.docker.com, so that's a URL you have to give it, hub.docker.com, and you need to always sign up. So sign up with your Gmail account. Okay, so already I have my Gmail account, and you could see that I have my account actually. Now, so here basically what happened, you know that hub.docker.com is like a public repository or it's like a public registry where all the images are placed here, right? And this is one of the way where what happened, right? Most of the organization they use this hub.docker.com to have their images placed in this actually, right? So for example, suppose whenever you want to keep your own customized image in a private repo, right? Then in that case, what happened, guys? After you are having an account, if you go to your account, can you see something like a my profile, right? If you click on the my profile, okay, my profile, you could see that you will be landing in this page only. In this page where your repos, you can create your own repos actually. This will act like a private repo for you. It means that you can able to push your images everything in this private repo. So if you go to the my profile, this is what your profile is, and here what happened. In this case, what happened that I have only one image. This is Raj Linux HPC, right? This is one of the image which you have designed and which you have kept it here actually. Okay, so now we will be learning about all these things in our upcoming session, guys. How to push the image, how to pull the image right now. But here you could see that actually, like whenever you want to use this image, actually, you could see that they are given the command actually, Docker pull Raj Linux SPC. So if I try to copy this and if I go and run over here and let's see whether it will run or not. So I could see that you're able to pull it actually because even though you are kept under your profile, it still act like a public repo only, right? You are not made as a privatization. There you can even restrict the permission. You can make that image to be as a private image where nobody can able to pull that image. Only if you're given any permission, right, for those people only, you will get that. You can able to pull it. But here in this case, what happened? Whatever this image is there, which I have kept here under my profile, this is a public repo only. But what I'm trying to tell you here that suppose you are building your own customized image, you can able to keep your image under your profile. So this is your profile. So under my profile, you can keep all your customized image which you have built. Okay, but in the organization, like if you see it, basically what happened, right? Whether they try to keep all the customized image which the company builds for their application, whether they're going to keep in hub.docker.com, yes, they can keep it. They can keep as a private registry. Or else what happened, right? They can have their own private registry set up in their organization, which is something like a Docker private registry, right? Or else you can keep your private registry in any of the cloud platform. Like for example, you have a AWS ECR is there. Okay, Azure's ACR is there, and Google's GCR is there. So you can even keep anywhere these images. So even either in the cloud platform, you can keep all your customized image under the private repo, or else you can have your own private registry which you can set up in your organization, and you can push all your images everything under the private registry, or else you can even put in your hub.docker.com also. Anywhere you can put it, but most frequently repos which repository or registries which are used in organizations are, it will be either private registries which they set it up in their organization, or else they will go with the cloud platform. These are the only two things which I see mostly most of the organizations they follow it actually. Right now, what we are going to do, guys, in our upcoming sessions, we will be understanding about like how this hub.docker.com works actually. That is one thing. And second important there, how you are going to create a customized image and how you are going to do all kind of activity. Like for example, Docker push and the image name you will push into a repository, and Docker pull. All those Docker pull, Docker push, commands we will be using heavily in our upcoming sessions. Okay. Now, okay. Now, whenever you want to search for any image, basically, here you could see that in hub.docker.com, you could see that search for Docker Hub. If you just click on this, you will see that there are something like there are three categories are there: Docker official image, verified publisher, and sponsored OSS. These are the three stuffs which are there. If you go to the Docker official images, and these are the official image. If you come here and if you click on see all search, right, you will see that you will get all the official images actually, right? These are all the official image built by the Docker community only. Like for example, you have Nginx. So suppose tomorrow you say that Rajesh, I want to run my web application on the Nginx. So I need a environment or I need an image already. It has an Nginx installed, predefined or installed it. Can I get any image as such? Yes, you will have an image with the name Nginx itself. So you can download this image nginx and you can place all your web pages here. You can even do some of the configuration and you can run that your nginx image as a container actually. So similarly, you have something as an Alpine image. Alpine is basically it's a kind of an OS image. Here, Alpine image basically it's a very light Linux kind of a image which you are going to get it from hub.docker.com. With this, what happened, right? You will get a very small, a very base image of the Linux. You're going to get it. Now, if you see over here, if you just say Docker image ls, now you could see that guys actually that you have a Ubuntu 24.22.04, which is something like it is of a size something like 119 MB, right? So this is something a large image actually, right? Very big image because this is a Ubuntu Linux which has all the content inside it. It has all the commands, all the packages are installed. It's like a bulk image actually. But in the real time, when we are working on customizing any of our application to run under any kind of a Linux OS, if you take the Ubuntu, so what happened, right? By default, you get 119 MB of that image itself. On top of it, you will be building your application. Though obviously the size of your image will grow more than 119 MB. You will see that 190 MB or sometimes you will give more than 200 MB. So that size is very big size, large size. And when you are working on building an application, right, and you are using Ubuntu image, that is not feasible because Ubuntu itself will take a lot of disk space. And on top of that, you are actually running your application inside that image or inside that Ubuntu. Then obviously the image what you're totally finally when you're coming up, that image size will be very large size. So you in the real time, what happened? One of the constraints of building an image that your image size should be very small size. In that case, what happened in the industry? What they do that instead of using Ubuntu 22.0.04 or Ubuntu latest, whichever image, can I use any kind of a lightweight image? Where so one of the lightweight image is not but the Alpine. Now, if you try to copy this, if you try to click on it, you could see that he is just saying Docker pull Alpine. So let me copy this command, come over here and then run it. Now you could see that guys, you're pulling a Alpine image. If I try to do a Docker image ls, you could see that guys, you have downloaded the Alpine latest image. This is kind of a Linux image itself, but you could see that the image size is 13 MB. So it's very small compared to this Ubuntu image actually. So why this image is very small, Alpine image? Because guys, this Alpine image, it's like a Linux image itself. It doesn't have all the utility in it actually. And also it doesn't have all the commands. So it will be a very lightweight image with very less utility and with very less command they have built it. So for many purposes, we use this Alpine image, guys. Even today also in many of the organization, they use this Alpine image because whenever they want to run any of their application into any kind of a lightweight Linux operating system they need it, they use with the Alpine image. Now the second question comes, do you have any other image light Linux images which are lighter than Alpine? Yes, we have many of the images. What are those? We will discuss in our upcoming session. Okay, but right now you can understand that usually whenever we want to run any application and it needs an operating system like Ubuntu or any CentOS, right? We usually don't go with this big applications with these big images because the sizes are large actually. Similarly, if you try to do one more image, if I try to do a Docker image, Docker pull, there is an image by name CentOS. I think CentOS colon CentOS. Okay, I think CentOS. I'll just say CentOS. Let's see whether I'm trying to download or not. CentOS is not there. Okay, then if I try to go here and if I try to just search for CentOS, let's see guys whether I have CentOS or not. See, you have a CentOS actually, right? CentOS operating system. If you come down, see, they are given this is the image, right? CentOS pull. So if I try to copy this, you could see that the last update was 3 years ago because and the size is 72.6 MB. See, they have already given it. So compared to your Ubuntu image, as per here, compared to your Ubuntu image, CentOS image is size is a little bit smaller. So usually people will go with this image also, right? But what happened because CentOS is been CentOS 7.8 has been no, they stopped giving any kind of a support, guys. So if you're facing any kind of a problem with this image, right? Okay, you will not get that much of support actually. So people who are using this image from long time, they know about that this CentOS image, right, which they have 7.9 or 8 version, it doesn't have much support community. So usually what happen, people will try to they don't want to take any kind of risk right? By going with some distribution of Linux where there is no more support available. So usually people will go with Alpine, people go with something like Ubuntu, where you'll get some kind of a good support, or you'll get a lot of good help articles, everything, right? Where you will get some kind of a solution if you got stuck up by using these images at your while building an image. But whereas this one, yeah, I mean, you can't guarantee. That's what people don't go with this. So they'll always see like when was the last build time, when was the last image which got built out. You could see that actually it was built about 3 years ago. So usually people will avoid using any kind of image which was which was last built out for a very long time. Usually people will go with the very latest one, maybe like few days before, 8 days before, 10 days before, 2 days before this image got built, right? Only that kind of an image only people go with it. And here you can even see that it's already saying that it's been deprecated. The official build of CentOS. It's been deprecated means people are not using at all. But still, I mean saying that we have an option actually. And if you try to do a Docker imageless, you could see that we are having a CentOS also. And our content size image is 300 MB. Oh, it's a very large image, man. Okay. Okay, this is not feasible actually. Okay. Okay, guys. So we will try to discuss about all other lightweight images. Okay, and also we come across something like slim images. We'll try to come across with something that destroless images. We'll try to come with all those images where you will get a lot of lightweight Linux images. You're going to get it actually, and that is the best practice. You have to use either the slim images or Alpine image, or else destroless images have to be used at your work level when you are building, when you want any kind of a lightweight Linux image actually, right? Now here, coming back here in the hub.docker.com, so if you are going with this official images, click on official image, go to the see all search, you will get plenty of what happened, you will get a plenty of images, guys. You're going to get it. More than 5,000 images are there actually. More than 5,000 images are there. You could see that a lot of images are there. And for each and every images, guys, whatever they're given, right, they have given an information about like how to use that image. For example, if you want to use a MySQL image, so I think in the last class also we had discussed it. If you go with the MySQL image, okay, and if you come over here, you will get that so many image tags you're going to get or versions you're going to get. Like for example, MySQL colon 9.5.0, MySQL colon latest, which is about the latest build, MySQL colon 8.4.7. So whichever version of the MySQL you need, you will get a plenty of supported tags, right? You're going to get it. You can use any of these actually based on your requirement. And if you come down, they are given some kind of a information about like where you will get that images and all, and how to suppose you want to like if you're finding any issues actually, and then like you have to really connect with the people who are working on a MySQL image, right? You can even raise your issue here in this link actually. How to file an issue here? If you go and click on here, you can just raise your issue actually. You could see that there is something like issue is there. You can go and click on the new issue, and then like you can log your new issue, whatever is there. See, so many people have logged their issues. So like this, they are given the links, and also you could see that actually that your images are supported by multiple platforms, but you could see that it supports on AMD 64 and ARM 64, x86 64, like that. You have different architectures which is supported, right? So they build this image so that it supports on multiple architecture or multiple platforms, you say, right? And if you come down here, they would have given an elaborate description of what is MySQL is all about, what are the things you can achieve through this MySQL image. And if you come down, they would have given how to start with this using these images, how to run the image, how to use this image in a command line by using a Docker command. They would have given multiple information, guys. And usually what happens, people whenever they try to use any of this image in their work, right, they'll usually go with this entire information. Even though it looks very lengthy, right, people will usually go with and they try to understand what is this image is all about and how to use it and what are all the stuffs you can able to achieve through this image. They will get all this information with the help of this documentation. So always it is a best practice, guys. Whenever we try to use any image from the hub.docker.com, please try to go and try to read this information about that image. Just try to spend 5 to 10 minutes of time in understanding this, because this will give a great information about that image, and also you'll get some very important points from this documentation, where that will be helpful for you to, even when you're working on creating in your image, right? When you're using this customized, when you're using this official image, you will get to know how to use that image at your real time, right? So please have a habit of reading this document also, right? Okay. Now, one thing what you have watched carefully is that actually, that when you are trying to go with the official images, actually, you see that the image is having with only with a single name, like memcached. After that, there's nothing is there. Nginx. See, so it means that we are only seeing that image with only with the image name. You don't have any kind of other special characters or something, right? But if you go here and if you try to go with a verified publisher and go here, see all image, right? And if you go with the verified images, see, I'm going with a verified publisher image. You could see that you will find many other images also. But you could see that it is having with some name, like for example, Datadog slash agent, Bitnami slash kubectl, Grafana slash Grafana. So what I'm saying means this category, right? Verified publisher. It is something like where an external person who is an outsider or the third party person, they will try to build an image actually. When they are building an image actually, right? What the naming convention should the image name is that whichever community who is building an image, that community name will be there. Like for example, Datadog is a community or the company. Okay, they have building the image and they will give their own name, official name, that is number Datadog slash, and then they will give that image name actually. So, for example, in my case, my name is my account name is Raj Linux. So, whenever I'm building an image, I'll have an image name something like Raj Linux slash something like my application, my app, something like that, and I will give the version number, right? For example, here, something like this Raj Linux slash my web image colon 1.0, like this. So it means that if I am a third party person and if I'm building any image, I have to give this convention like this actually. So tomorrow I'm trying to do some more modification to the same image. So what I will do that I will just release one more image with this my web image, and I'll give the tag as 2.0, something like this. So similarly, what happened? The company like Datadog is there, company like Grafana is there. So Grafana is a company, or they have an account with the name Grafana under the hub.docker.com. And under that, what happened that they are giving an image and they call it as something like a local image. So these are actual image, but conventionally, when you're trying to when you want to use this image Loki, okay, you have to give the complete path, the whole path name or the whole path you have to give like this. So if you go here, if you try to just say Grafana Loki, see how you want to pull that image. See Docker pull Grafana slash Loki main something whatever is there. This is how you have to pull that image. So if you try to copy this command and come over here and just try to run this command. See guys, you are pulling that image actually. Grafana slash Loki. So Grafana is nothing but you can understand it as a user, and slash Loki is the actual image name actually. Now, if I try to do a Docker image ls, you could see that, you could see that, see, Grafana slash Loki colon, this is what the image which you have pulled actually. Am I clear, sir? But whereas an Alpine or Centaurs or other things, right, it doesn't have that kind of a special kind of slash. But for the Raj Linux, you could see I have built my image Raj Linux slash SPC 1.0 colon later. See, this is the tagging actually which I'm using. Here in this case, the tag is main hyphen 8.0. This is a tag for this. So what I'm trying to say that whenever any kind of a third party company are developing an image, and when they are posting that image, when they are pushing that image into your hub.docker.com, usually it has that slash in between. So with this, you can make out that, oh, it's a third party image actually, which is a trustable image, which is a verified publisher image. You can use it. You can use it in sense like you can even use this image in your production also. Like when you are trying to build any kind of a application which you want to develop and push into production, yes, definitely you can use this image. There is no issue with that. It doesn't have any kind of a vulnerability issue in this images and all. Right? You can use it because it is widely, it has been verified and it has been published. Right? So the native who developed it, the native cloud native log aggregation by this is the organization which they developed it actually, right? And they would have given all the how to run this image and what everything. They would have given all this information, guys. You have to go through this information always. So now what I'm trying to say that if you try to go here, the official Docker image itself will come with a single name. But as a verified publisher or it's even sponsored OSS, they come along with something as a slash in between. So if you go to the sponsored OSS, and if you come down and if you try to click on it, okay, I think here it's all got selected. Let me remove this verified and I'll just go with the sponsored OS. See, even sponsored OS also will come something with a slash actually, right? For example, Istio, Proxy V2, Istio Pilot, right? Istio is an organization who developed this, and while pushing it, they gave Istio slash Proxy V2 actually, right? So you could see that all this. So usually what happen, you can even use this, like sponsored OS also, you can use this image at your workplace. You can use these images basically. Am I clear, sir? So, guys, still here? Are you okay?
Grafana hyphen
Hmm.
slash Loki. So Grafana is the organization and Loki is
Yeah,
the
like how
user.
I have logged in as Raj Linux, right? Grafana
Hmm.
organization, they log in as a Grafana. They have
Yeah.
an account with
What
the name Grafana. Similarly, Istio has an account in the Docker Hub as Istio.
what about that proxy V2?
That is a name, like how I have
Hmm.
given. For example,
Hmm.
here, Raj Linux. Okay, I gave my image name with SPC 1.0. Similarly, that organization, when they develop this application, when they develop an image, they give given some the proxy V2.
Okay.
Yeah, like that they will get proxy, see, Istio operative, like that. So Jenkins, they would have created this with this image. Right? Open policy agent, that's an organization, but while creating a image name, they would have given something like gatekeeper or a radar, something. This is what the slash, whenever you see slash means it's a third party. Some external organization apart from Docker who has built an image and who has provided that image in your hub.docker.com. So only these are the three trusted contents which are supported by your Docker community, guys. One is an official and others a verified publisher, others a sponsored OSS. Okay, good. Of course, like as I said, right, you will get a slim image, you will get what they call distro images, which are lightweight images, and also there's something like a perforce actually. Suppose you want to do some kind of a performance activity with the help of that image, you will get some image with the name perforce. Like for example, OpenJDK 17:17 hyphen perforce, like that you're going to get like this. We'll also discuss about that also. Like for example, OpenJDK. I'm just giving an example. Colon 17 hyphen perforce. So there are various different conventions are there in the images, guys. We will discuss all about that in our upcoming session. Okay, fine, guys. How to create an image, our own customized image, and how to push that image and all, we will see in some time. Don't worry. That is very much important for all of us because we need to build our own customized image and then we have to push that image. The way I pushed my image, right? For example, here in my case, if I come to my profile, you have seen that I have built an image on the SPC colon 1. I pushed it actually. Basically, I developed that image in my local system. And from my local system, I pushed into the hub.docker.com. How to do that? Basically, sorry, you have to use a image or you have to use a command as a Docker push command actually. Docker image push command and specify it. So how to do that everything we will see in some time now. Like if not in today's session, yeah, definitely tomorrow session we'll be learning about all those things. Is it fine, guys? So it's quite interesting for all of us to learn about how to build an image, as I said, and how to push that image, how to manage all those images. everything. It's very important for all of us. That is like kind of a bread and butter for the DevOps engineers, that we should know about how to play around with creating these images and build that image, and then finally push that image into your into your repositories actually. Right now, it's so far like we have been learning or understanding about all these images, right? We have been hearing a lot about these images, uh, right? But let us try to understand what is this image is all about, right? We know that image is something which is required for you to run a container, right? Because without any image, you cannot run any container. Similarly, suppose I want to run an application, right? Without an operating system, I cannot run an application, right? So it means that whenever you want to run an application, you need an environment where you can run an application, where you can get all kind of environment to run it. It means that your application, it needs a lot of resources. It needs a storage, it needs a networking, it needs some kind of a runtime environment, it needs some kind of a libraries, it needs some kind of an environment variables to run it. So your application, when you want to run any application, it needs many of the resources it needs to run. Similarly, whenever I want to run any application inside my Docker container, that application should be built as an image actually. Without an image, you cannot just take an application. Suppose I have my Java application. Assume that I have a Java application. For example, I have something like a Spring Pet Clinic, colon something 1.0 hyphen something dot jar file is there. This jar file is there. This is a jar file, and whenever you want to run this jar file, what you do basically, you will install the Java in your Linux machine or in your Windows machine. There you run this command java-jar and specify this jar file like this. You are going to run your application like this. But Rajesh, the same, I want to run the same image. I want to create the same. I want to take the same jar and I have to run inside a container. So inside the container, what happened? That you cannot just simply go and execute this command like that. It will not accept. Right. So what Docker says that whenever you want to run inside, whenever you want to, whenever you want to run the application or app inside the container, then you can do with the help of an image actually. So with the help of an image only, you'll be able to run your application. So it means that I want to come up with my application with my new image, which has this jar file as well as it has this command also. Yes, it means that you need to include both these things with your image, and you need to run that image. And when you run the image, this application will be start running like this. If you remember, guys, in our last to last session, right, we created some container, something like a Ubuntu container. You remember? You had run a Ubuntu container image. So inside the Ubuntu container image, what we did, right, we tried to have the SPC image like this, SPC colon 1.0. And we run that application inside the Ubuntu image, right? So for that, what we did basically, guys, you remember that I had a Ubuntu image. If you watch last to last video, in that latest image, what I did, right? I tried to install something like HTTP image. And after that, what happened, right? You got some folder structure by name /www.html. Under this HTML, what happened, right? You will be able to place your template for anything and you can run it. Similarly, under your Ubuntu, or else you can take some kind of a same thing. Ubuntu image, you can run it, and then like you can install the Java OpenJDK. Inside that OpenJDK 17, and after that, what happened, right? You can run a command java-jar command and specify your file actually like this. So you can do we were able to do all these things, guys, by running our application inside the container actually. But is the right way to do it? Whatever we did, no, last previous class, this is not the right way, guys, because this is not. This is something like the way you do in your virtual machine. Right? The same thing you're trying to do in a container. It means that you run some Ubuntu container and you try to install some software required for it, like for example Java, and then take your image, try to copy this Java of a jar into your into your running container, and then run that application. Right? Run this means run this command, so that you will make your application run. So this is not the correct way. we do it actually. But usually after some time, what happened that we need to understand about how to build our own image, custom image. In that custom image, we have all these things. We have a Java installed. We have a your jar file copied, as well as you are running this command also. So all the things should be a part of your image. And when you're just creating or when you're running a container with your image, actually, it should even run your application also. That is what ultimate requirement is, that you need to build an image such a way that while running a container itself, your image has to start your application. That is our main intention. That is why what happened that we build our own custom images. Okay, so now let us try to understand a little bit. We'll try to dig into more into what is this image is all about. Okay, and how to build an image and all. We'll see it in some time. But basically, uh, we will see like how what are the different ways of building an image. We will see that also, and we will one of the very important way of building an image is through writing a Docker file. So that is an important topic. We all have to understand more, and we need to spend more time in writing a Docker file, right? What is a Docker file about? No problem, guys. We are going to discuss all those things very soon now. Okay. So now let us try to quickly understand, or let us try to quickly write certain points on what is the image is all about. So let us try to understand about what are Docker images actually. So basically what happened, guys, Docker images is nothing but it's a, I can say, uh, Docker image is essentially, I can just say as a blueprint, or I can say that it's a recipe kind of a thing that contains all the instructions needed to create a Docker container. Right, guys? So whenever you want to run any application in a Docker container, you need a Docker image. So it is something like a recipe, or it's like a blueprint that contain all your instructions to run an application. Right? So usually what happens, your images, what exactly the image contains? The image contains the code, a runtime environment. Okay, and what are things? It also contains the libraries, variables, and also configuration files. This is what your image contains inside. So when you try to take any image, so if you try to dissect that image and check it out, what are the it contains? It basically contains the code, the runtime environment, libraries, variables, and also the configuration files. Clear, sir? Now, whenever we are building an image, guys, we are building an image as a platform independent. It means that suppose you're having a Docker installed in your Linux machine, you can take your image and you can run your image in, no, inside a Docker host where the Docker host is actually installed in the Linux machine. Similarly, you can take the same image and you can even run in your operating somewhere in Ubuntu or in Windows where Docker is installed. You can run your image. So you can basically run your Docker content in any platform. If your Docker is installed in Windows or Linux or Mac OS anywhere, that's what happened whenever you are building a Docker image, we build as a platform independent. It means that it can run anywhere. So Docker images are platform independent. You cannot restrict. You cannot say that no, I will only run on Ubuntu where on top of Linux. No, I can't say like that because in the customer end, right, you can have a Docker installed in any platform. Yeah, they would have already installed in Mac OS, they would install in Windows or anywhere, right? Whichever operating system they installed, everywhere your image should be supported actually. So hence, while building a Docker image, it should be a platform independent. Meaning, what is it? What does the meaning means? They can be created on one system and used to run the container on any other system. Any systems with Docker installed. Right, guys? Now, fine. Now we saw that, okay, this is what the Docker image is all about. Now, how to use that image, how to do it actually, basically, we know that you are having something hub.docker.com. We know this. And whenever you want to use any kind of image, basically, you will get all kind of images in your hub.docker.com. You try to do something like a pulling the image you do. Basically, we have to always use something like a pulling of the images, right? pulling of the images basically. And what are the other activity do? Sir, I will pull the image from the hub.docker.com. I want to push that image. I'll be using something later. First, I will try to pull it. Later, if you want to create any new image, I will try to create an images. And finally, what to do that? I want to push that images, pushing of the images. These are the certain activities, guys, where you perform when you're working with your images actually. And also, it's not only pushing and pulling. You have to even manage the manages also. You have to even manage the images also. Manage the image sensor. It's not like one-time activity, guys, because you will be doing a lot of enhancement for your images. You will be releasing a new version of your images. Hence, what happened? You will be keep working on developing the image, and you try to push the images with latest versions. Whatever you do, the changes actually. So management also will become quite not challenging. Management of the image, something like you will be keep building a new versions of the images actually, and the same image will be pushing in your repositories also, right? So we need to learn about all these things, guys. We have to know how to pull the image, how to create the image, and how to push the images, right? Now, so now whenever you want to run in any of your application, basically what happened that you need to have your images, you need to pull an image, you need to use the image actually. What is the two ways actually? So pulling of the images. So basically what happened, right? There are two main ways to get the images, to get the token images. One is that actually pulling the image from Docker Hub. This we know it. And the second is that actually creating your own images actually. Okay. Now we saw that actually when you're trying to pull any image, you could see that actually all your images comes and it will be placed in your system. These are all the images which are there. So how do you do it? You just did a Docker pull and the image name. It got all those images got pulled from the hub.docker.com, and you got those all those images in your local system. Right, guys? So tomorrow you might say that Rajesh, I am building some application where my applications are PHP based application. Yes. Can I get an environment where I can run my PHP application? Yes, you can go to your hub.docker.com here, and what you can do that you can just go and you can just search for PHP. Just check if there is any kind of a PHP image exist in your. You could see that. See, this is a PHP image. So this is a official PHP image. If you click on this, you will get all the details. As I said, right, you'll get all the details of what is the version you want to use it, you want it, and then if you come down, how to use that image, right? How you can run your PHP web application by using these images. All details you'll get it here, guys. Actually, so we will be going through all this information about like how you can able to run your own PHP application using this image actually, right? Okay, guys, good. Now, okay. Now, so basically, okay. Now what happened, right? Let us try to understand about what is this creating the images basically. So usually what happened, guys, when you create an image, basically you will try to create your customized image. You will create the customized images. And what you do basically, right, you will try to keep your customized image in your repositories actually. So you will try to keep in your hub.docker.com. This is a repository. This is called as a public repo. You will try to keep your newly customized image in your public repo actually, right? So basically what happened, right? Your hub.docker.com, it is a public registry, we say, for all pre-built pre-built Docker images, as well as to keep your customized images also. So we know that what is this hub.docker.com? These are public repository guys actually, but it acts like it is like a, I can say like a giant app store, right? Which stores all for all containerized platform, right? Or containerized application. You will keep all your images, everything in this hub.docker.com. So this hub.docker.com is act like a very big giant client actually. Okay, sometimes people also say like hub.docker.com is like a marketplace. It's like a marketplace. It means that where you are going to get all kind of a where you will get all ready-made building templates actually. Okay. So your hub.docker.com is something like where, like you can kind of browse for anything, right? See, as I said, right, like if you want to go and search for any of the image, how we do, you go here and you try to search for any of your requirement with the help of here. So you try to go and search for it. For example, if I want to go and search for Redis, you could see that actually, see, you will get, so it is like a search actually. So whenever you want to search for any kind of a requirement, right, usually you go with hub.docker.com and then search for it, you will get that image. You can use that official image for your requirement. So here what happened, right? Your hub.docker.com, your hub.docker, right? Basically, it is used as browsing the images for all sorts of softwares, right? Like for example, like from popular databases like MySQL to some to any kind of a web application also. For example, if you want to have a web application framework, you need. For example, I want to have a web application framework like Node.js actually. You can even get that also everywhere here in your hub.docker.com. Okay, guys. Good. Now, what are the things you have? Creating image, yeah, pulling the image, pushing the image. Yeah, yeah, we use this actually. Yes. Okay, let me write how to pull the image. How to pull the image. Basically, we use some commands like this. Docker pull. Okay. The name of the image, colon. I'll also give something like a tag actually. To this command, okay, this will what happen, right? This will download an image actually. If no tag is specified, if no tag is specified, then latest will be pulled actually. Like for example, if I try to do just a Docker pull Nginx, what it'll do by default, it'll try to pull the Nginx colon latest actually, right? Suppose you want to have some kind of a version like 18.4 or 18 something, you have to just say Docker pull Nginx, and then like you need to put the tag actually like 18.0 or 18.02 something like that. Then you need to mention this tag actually. Without this tag, it'll try to understand that you want to put the latest image. It'll try to put the latest Nginx colon. So Nginx latest colon, it'll try to pull it. If you want to have a particular version, then you need to give this tag actually. So which is very important for all of us, that whenever working on any kind of image, always you have to make sure the tag has to be provided properly. If you're not providing any tag, it understand it as a latest image actually. Am I clear, sir? Right? Okay, good. Okay, what else you have, guys? Okay. So, what else is there? Okay, if I want to list the image also, yeah, list image, listing the images. Okay, we know these guys because we already did everything. I'm just trying to write. So after pulling the images, or after pulling the images, list out all the downloaded images. Okay, with the command What is that? Docker images and say ls. This is the command we do actually. Docker image ls. Am I clear, sir? Now, how to create an image actually, right? So now the next is how to create images. There are broadly there are multiple ways are there how to create an image. Okay. So one we know that actually Rajesh, one what I do basically one is something like I want to pull the image from the Docker up. That is one thing which you do it always. Remember that I use an already existing image. Or as the next second is that actually I want to creating your own image actually. This is what we are more interested because in your work when you work on the real time guys, you will not be always be using some custom. You will not be using the image which is there in your hub.docker.com. You have to create a customized image. Okay, that is what we'll always be doing actually, right? So, right, basically, right. So you have to use a customized image actually. So what is this customized image all about, or why you need to build a customized image basically? See, customized image basically we build for our own requirement. So, for example, you have your application and you want to run some specific software in your application, right? Some specific version, and you need to provide some kind of a settings. Hence, what happened? We build our own image actually, right? So it means that to build a name custom image. What is the custom image? Customized image will let you set up exactly what your application requires or what your application needs to run. Like specific, what can I say, software versions you want to run and some kind of a settings you want to make, right? That's what happened that you will try to build your own customized images actually. Okay. So customized image, custom images let you include your specific libraries, any kind of a dependencies, and your application code and your application code for your project for your project resulting in resulting in running and securing your images actually. So that's what guys we always try to build our own customized images actually. So in the organization basically what happened, right? Whenever you want to host your application, your customized application, like you need to build your own customized image, and that customized image you will try to run in your Docker container. And usually what happens, guys, whenever you're trying to build the image, basically, you follow some process, you follow some kind of a DevOps process to achieve all these things. Usually what happens is, we try to build a CI/CD pipeline, and through the CI/CD pipeline, what happened, basically, you try to do some kind of integration, right, to achieve the completely automated process, actually. For deploying any application, you follow a CI/CD pipeline integration method, actually, right? That's what in the real time we do, actually. So by creating an image, by creating a customized image, or by creating a custom image, you can streamline and the automate the deployment process, especially when I can say especially when I can say integrating with the CI/CD pipeline or CI/CD engine or CI/CD pipelines. Okay. So usually what happened, right? Whenever you are after building an image, what happened, right? You will be storing your image locally in your system. So Rajesh, if I build an image here, yeah, my image exists in my system only here only, right? My image will exist in my system only. It will be it will be locally placed. But do you really keep everything your image, everything a local? in the local system only. No, we have to share this image across multiple people within the organization. Then you need to push that image, or you have to keep the image into your repositories. Either you will go and keep your images, all your customers which you have built in your local system, you try to push that image into the hub.docker.com, or else you will try to push into your private registries which you have already set in your organization, or else you can even push into something like in the cloud platform like ECR, ACR, or GCR, right? Wherever you want, you can keep it actually. So what I'm trying to say that after post creation of custom image, after creating a custom image, okay, okay, which is initially stored locally, okay, it is initially stored locally. So what happened, right? You will try to keep the images into the into the into the registries, into the registries. Like for example, you have a hub.docker.com. So this is nothing but your public registry where you'll try to keep your image. You'll try to push and keep that image. Second is that you can even keep in your private registries also. It means that you will have your local private registry set up within your organization. Within your organization. And the last is that actually like you will try to keep everything in your cloud registry. Like for example, you can keep your image under your ECR, Elastic Container Registry in AWS. Similarly, you have ACR, which is but Azure Container Registry, which is in Azure Cloud, and similarly you have GCR, known as a Google Cloud Registry, which is in a Google Cloud. So you can keep anywhere, guys. Right? It's your choice actually. It's a company's decision to keep these images. So usually when you build an image, everything right locally in your system, finally you push that image in your public repository like hub.docker.com or private, or else any of the cloud registries also can keep it. Right? Fine, guys. Good. Now, hmm, now the question comes, Rajesh, why we push it actually? Why we try to keep everything in our in this repository? Why we have to keep it actually? So, or else the question might come, why do you really push these images into it actually? See, the first important thing is, guys, actually, that why we do this, why we want to keep it everything, because you might be keeping all your images locally in your system. Here, you might be keeping everywhere in your system. Like if I try to do a Docker image ls, you are having all your images in your locally, but you want to share these images to the other person within an organization. How do you share it actually? You can share it because you have to keep all your repositories in some kind of a registry. That's what happened. You want to share it means you have to keep everything in your some of the registries actually. That's what either you will go with your own customized private registry, or else you will go with the cloud platform where you can go and push it. That is one usage actually. The second is that you might be keeping all your images locally. Suddenly assume that your server goes down, or this your Docker host itself will go down. It means that you will be losing all the images. Hence, what happened, right? We will not take any kind of risk. Basically, you will try to keep all the images in our registers actually. Okay. And one more important thing is that actually, like when you're building an image, it's not only that you are only building an image. There are many people are there within your team who are working on the same project, who are building it. So you need to do some kind of a collaboration, and the distribution you have to do it actually. Hence, what happened? We always try to push all the images into the repository actually. And one more important thing is that actually it's not like it's a one-time activity, because you try to build a image, you'll be keep releasing a new version of the image. It means that you have to keep releasing a lot of versions of that same image. Hence, what happened, right? You need to always push into the repositories actually, right? These are the usage. This is what the reason like why we need to push the image. So the question might come, right? Why we need to push the image? Why we need to push the image? That's a question might come. And the reason for it is that it's a sharing made very easy. You need to share across the team or across the organization, right? You need to collaborate, and then like you need to do the distribution of it. Hence, what happened? You push that image actually. And finally, what happened that you need to maintain some kind of a versions of that image. Versions of that image. You will be creating a version of that images. Hence, what happened? It is always best practice that you need to always push everything. You have to put everything in your. And also, sometime like for the security point of view, also you will try to get. So security consideration is also there. Am I clear, sir? So how do you push it? Basically, we use the command docker push, and you need to give the username slash what is it slash repository your repo, okay, and give some tag actually something like some tag. This is the command which you use for pushing your image into your repositories actually. Am I clear, sir? Right. So that's how we do it actually. This name, username is nothing but we call it as a registry name actually. So if I want to tell you in a proper way, you have to just say docker push. One second, guys. Docker push. I'm just telling you theoretical now. We will do all the things practical, guys. Instead of username, I have to actually tell you something like register name actually. Like this, colon, what is it? Image name actually. Image name like this, colon and the version actually. Tag or the version what we. This is the Excel format actually of the Docker push command. Okay. Good. Now, whenever you want to understand about the image, what that image is all about, we use something which is inspect actually. For example, if I try to do a Docker image ls, it will list out all the images, right? And when I want to specifically check any kind of an image information, I use a Docker image inspect and the image name we will do it or image ID. Like for example, here, like Raj Linux SP is there. I want to check what is this image all about. Then I will use some commands, the Docker image inspect and the image name or the country or the image ID. This is the image name I'll give. Copy this whole image and like paste it like this. See, you'll be able to see the information about your image actually. Am I clear, sir? So we will go and deep dive in all these things, guys. Don't worry about what this inspect is all about. We will see all these things in our upcoming session. Okay. And one more important thing, which I've been keep stressing that when you build any image, when you're building any images, always please make sure that you have to give a proper tagging and also the proper versioning is also required. Okay. So why we do this proper tagging and proper versioning of the image? Because for to manage the to manage for better organization and version controls. Hence, we always use this tags properly, as or else we will try to keep the versioning properly for all the images actually. Now, whenever you have any image, you want to you want to set a tag for that. For that, there's a command, the docker tag command. So if I say docker tag, and if I say just say image name, right, and then I will use something like a registry name slash colon and the image name colon version. For example, here, guys, you have here, if I say Docker image ls, you have an image, Alpine image is there actually. Suppose you want to give some other tag or you want to create a tag. So what you give something like a Docker tag. Okay. Or else I think I will do it later, guys, because while building an image and all right, I will show at the time, not now. Yeah, otherwise it will confuse. But this is a command what you will be using for creating a tag or setting a new tag. So whenever you to set a new tag, you have to use a docker tag command. So I'll park it aside this command now. I will not explain now only because while creating a Docker file and or while explaining about what is a Docker file all about, you will get to know about what is a Docker tag command. But right now I don't want to tell anything. Like it might confuse. That's what I'm not able to explain you about Docker tag here itself actually. But anyhow, we'll try to understand this very soon actually, right? Okay, good guys. Now, and also one more thing I want to tell you, whenever you want to remove any kind of a tag, actually, sorry, whenever you want to remove any kind of images, so removing the images, how you are going to remove the images? So basically, guys, to remove the image, basically what happened, right? You try to do a command, run a command, the Docker, what is it? Image rm, and specify the image name. This is the command we use it. And we also use the same command last time also, right? If you remember, I want to remove the image. I'll just say docker image command, docker image rm, and then give the image name. Like for example, here Grafana Loki, something like this, right? So you will try to give this image name. So you could see that you have removed the image. So if you try to do a docker image ls, you could see that you have removed that Grafana Loki, right? So docker image rm command. If you want to do forcibly, you can just say -f and you can give your image name like this. Either you can give the image name or image ID. If you go give this image ID, right, you can even give this image ID also. It will remove that image actually. If you try to do a Docker image ls, you could see that you have removed the images. So always whenever we are out of the disk, right, we will try to remove all our old images, guys. Because if you start keeping all the images in your system, what happened, right? It will consume a lot of storages, and sometime what happened, your system server storage might go up more than 100%. Sometimes it happens like that. So hence what happened, you will not keep any image for more than 3 days in your system. So you'll try to set up something like a job where after 3 days, if any kind of image exists, right, please try to remove all those images which are 3 days back images, right? Those things and all, you try to remove everything in your system so that you will try to keep your storage in a health state actually. Am I clear, sir? Till here, sir. Guys, till here, are you okay?
Yes, Raj.
Okay, now what we're going to do that we will try to understand like how we can able to containerize the application using the Docker file. So one of the way, guys, one of the way to create a image or create a custom image to write a Docker file. So the topic is about containerizing application using Docker file. Now, what is this Docker file is all about, guys? Like for example, if you go to the Google and if you try to search for something like Docker file, just search for Docker file. Can you see something like Docker reference actually? Right. Also, it says that, or else, let me give it a Docker file. So, can you see something as a Docker file reference actually? So, if you click on it, so Docker can build an image automatically by reading the instruction from the Docker file. So, basically, we write a Docker file for building your customized image actually. A Docker file is a text document that contains all the commands a user could call on the command line to assemble the image. Okay, and this page describe the command you use it actually. So basically what happened, right? We trying to use some kind of a Docker instruction to build a Docker file actually, right? Now the instructions are something like this. Can you see here? The Docker supports all the following instructions. Add, arg, cmd, copy, entry point, env, expose, from, health check, label. You could see that there are so many are there. This we call it as a Docker instructions actually. Call the Docker instructions, right? So guys, this page, or this URL, so has a, it has, we can say it has this link, what is it actually? This link, it is a text file, I can just say, which contains all instructions to create a Docker image. So whenever we want to create a Docker image, guys, usually we tend to write a file by name Docker file. So always when you try to write any Docker file, always the D should be capital, rest all others will be in the lowercase. Now the question might come, Rajesh, do you have to always keep this as a standard way of writing a Docker file where the first character starts the capital D and rest all other small? Yes. Time being, I have to say yes that because that we will be following this convention of writing a Docker file. But moving forward, can I have any other name apart from this name? Yeah, you can have your own name also. I can have something like a Rajesh file or Mahesh file or my file. You can have any other conventional name. But today, at this point of time, we will try to stick that saying that, okay, whenever I want to build any Docker image, I need to have a file with this convention name where the first character is always capital uppercase, that is D actually, and rest all other are in a smaller case. So whenever I want to build any kind of an image, I will have a Docker file, right? In that inside a Docker file, I'll be using all those Docker instructions to write a Docker file. So with the help of the Docker instructions, I'll be able to create a Docker image actually. Am I clear, sir? All right. Now, so so usually what happened to build the image, we use or we write the Docker file, and the Docker file will have the instructions inside it in the following form. What is that following form you will have? Something like you will have something as an instruction and the value like this. This is the format you have. Instruction and the value. Okay. Docker file has lots of instruction supported. Right? Instruction support. For example, here, as I said, right? If you go here, these are the instructions actually. Add is an instruction, arg instruction, CMD. There are a lot of instructions are there. You will be using most of the instructions you will be using while writing a Docker file. Like for example, on build, run, shell, label, health check, from, expose, see, stop signal, USR, volume, work DR. These are all the instructions what you use it actually. Am I clear, sir? Okay. So a lot of instructions supported. So let's define some very popular instructions actually. So what are those popular instructions which usually use it actually when we are writing in a Docker file? The first important in that, guys, we'll always be using something as a from, and we'll also use something like a run, add, or else I can say it as a copy. Okay, add and copy. Many times we use CMD, expose, label, entry point. These are the most important instructions. We always use it whenever you are writing a Docker file, right? So here what happened, right? We have something as a from actually. So what do you mean by from instruction? From instruction, basically, it always define a base image. So from this instruction defines a base image. What do you mean by base image means basically, guys? See, basically what happened that whenever you are running an application, say for example, when we are running our Spring Pet Clinic, right? When we run our Spring Pet Clinic application, which is nothing but the Java Spring Boot application, right? So, so when we have our Spring Pet Clinic application, right? We have something a Spring Pet Clinic application. It's a Java based plus Spring Boot. They use a Spring Boot like kind of a library. They have used a Spring Boot to develop the Spring Pet Clinic application, right? And usually you can have the Spring Pet Cleaning application in the dot jar extension. It means that you, when you try to build an image of the Spring Pet Clinic, you will get something like dot jar, something like SPC colon something 1.0 jar file, something like that. You are build this jar file. Now you say that, Rajesh, I want to run this Java application. How do you run it? Basically, you need an operating system. It could be any operating system. It could be Linux, Windows, or Mac, or any operating system. Preferably, I go with the Linux operating system. On top of this Linux operating system, you need to install some kind of a Java version. Like Java 17 is a minimum version which is required. Yes. So on and with the help of the Java, you will be able to run your Spring Pet Clinic 1.0 jar file. This is what you need to have. It means that first you need to have an operating system, guys. That is some kind of a base thing which you needed. And on top of the operating system, you try to install the Java. And on top of Java, you try to run your Spring Pet Clinic application. So it means that there is a series of software stack is required for you to run the application, right? Similarly, like whenever you want to run any PHP-based application, you need to have an OS, and on that you will be installing something like a PHP admin. You'll be installing it, and also like there are many other related PHP packages are there which you install it. And after you install the PHP package, you will try to run all your PHP files or PHP application. You try to run under it actually. So it means that you need to have some kind of a software is required, software stack is required, right? So similarly, whenever you want any database, you know that I need to have first OS, and then you have to install some OS of database, something like MySQL database. And on top of this MySQL database, what happened that you will be able to host your database actually, or create a database or manage all your database with the help of it. So there is some kind of a dependencies is there always with it actually. So here, right? So similarly, what is happening is that like whenever you want to run, or whenever you are trying to create any kind of a Docker image, or sorry, whenever you're trying to develop a Docker file, you use this from instruction actually. So from instruction will define the base image. Okay, on which base image you're using. For example, you say that, Rajesh, I have my some HTML pages are there. Okay, I want to host all my web pages or website. I want to host it actually. So for that, you need some kind of a web server. Either you will go with the Apache web server, or else you will go either with the Nginx web server, because you will be hosting all your websites under your web server, right? So now you will say that, Rajesh, let me go with the Nginx. So what you will do, you will take an operating system OS, you will try to install an Nginx on that, and after that, you have to keep all your source of all your websites, everything under some path. Say for example, you will keep something on /www.html. This is a path where you will keep all your website templates. Website template means all your CSS plus all your HTML files plus all your configuration things, everything you are going to keep it everything in this path, right? So with the help of this, what happened that you are able to host your website under the Nginx web server, right? Now, if you try say that, Rajesh, I need the same thing, whatever you did, right? I need a same thing in our Docker container. I want to do the same thing. So one of the ways that actually that you can use the official Nginx image. You can say the Nginx image, you can take it. So when you try to have an Nginx image running, that Nginx image will provide you an environment where you can host all your application, all your website, or all your websites or HTML application, you can host it actually. So when you try to have an image, basically you'll get an environment where you can host all your. It means that you can take all this website templates, everything, and you can place everything inside your image actually. It means that once you run it, later you can able to put all your application, HTML pages, CSS, all the whole templates, everything you can keep inside this image actually, or into the running image. This is one way what we do it. And also I think I have already covered this thing in our last class, guys. If you remember, last to last session we had seen all these things. Right. So now the thing is that you say that, Rajesh, now I want to build my own customized image. Okay. And my custom image, what is the purpose of building custom is that I have some kind of a website where I want to host my website, or I want to run my website, everything inside my Docker container. Okay. Then in that case, guys, when you are developing a doc, you need to develop a Docker file. Yes. And to develop a Docker file, you have to use a from instruction. Yes. And you need to use some kind of a base image. Okay. Let me do this. Let me use something like a Nginx as my base image. Okay. It means that you need to use that base image. It means that from somewhere you have to start it, right? Some base image should be there, right? On top of that base image will be your base image only. You will be running your application or you want to host your application. So that is something like you have a from instruction. We use it actually. So here, if you go here, this is the from instruction. From is create a new image stage from the base image itself. Or else what I mentioned here, this instruction defines the base image, right? So if you go and if you click on this from image, sorry, from instruction, you could see that guys, this is what the instruction is all about. See, you can use a from, yes, and you can mention the platform, yes, you can mention as an image and then as image. This is the format what we use it actually. Here what happened, you can even build your image into a specific platform. For example, you want to build for ARM platform, you can use a ARM as a hyphen FN platform is equal to ARM 64, or as you are building for your x86 platform, you can build for x86 platforms like this, right? And you have to give the image name. For example, you want to use something as I said mentioned earlier, right? You will be using something like a Nginx image, right? You want to use it actually, so you have to give from and space image name like Nginx. Suppose if you're not giving any kind of a tag, actually, it will take a latest image, or else you have to specify tag, you have to take a specific tag. As a name, this is something extra, guys, which we'll be learning about this about later. What is it? We'll see later. Don't worry now. So it means that basically my initial requirement is that actually I have to use a from instruction and I have to use some image. And with that, I if there is any tag is there, like some example, something, I can even mention a tag also like this. So it means that you are ready to use this image with the help of a from instruction. Am I clear, sir, till here? Yes. Now, you want to pass any kind of a meta information while writing a Docker file. In that case, you will be using some instruction known as a label. Label is something like this is used to add the metadata information. Okay. Apart from that, there is something like a run is there. Very important, run is there. So if you go back here, guys, one more thing. If you try to go with any Docker instruction, suppose if I'm going with the from, okay, you have to make a habit of going through some of the information about this here in this page itself. Actually, you could see that you'll get many options like this, right? So usually what happened, you can go with this from instructions and you can read all this information which they are provided in the from section actually, right? And similarly with the label also. Suppose if you go here, if you go to the label, see, it adds all the metadata. See, as the name says, see, label means it adds a metadata to the image. Suppose you want to pass some information to your image itself, then you can call this as a label actually. So if when you try to do practically all these things, guys, we will learn everything in a perfect way, right? So that's what. And then like there is something like a run is there. It executes a build command. Okay, it means that actually run image, run instruction, sorry, run instruction. What happened? This runs a command during image building. If you remember, guys, whenever I want to install any kind of a software in my Ubuntu, what you do, but you try to launch the Ubuntu Linux, Ubuntu 24.04. In case of our AWS, right, we go and launch the Ubuntu image. And what you do after that, like you will log in into that OS. And what you execute some commands, something like you just say, Rajesh, you just say sudo apt update like this. This is the instruction I'll do. Okay. Apart from that, you run many other commands like sudo, what is that? Something app install something wget command. I want to install it. I want the zip command. I have to install zip command. I want to even install some kind of other things like curl command. I want to install it. I want to install the curl command with hyphen I option. Again, you want to install some kind of some kind of a web server. What you do, you will do a sudo app install something like nginx hyphen y or else apache 2 hyphen y, whatever. I mean, whatever you want to install it, you install it like this. Now, guys, what happened that this is a kind of a commands where you're installing inside your operating system. It means that once you log in within in your OS, you try to run all these commands. Similarly, I want to do the same activity when I'm building an image. It means that when I'm having a base image as Nginx, I want to perform some action, or I want to install some kind of a commands, I want to run some commands, or I want to install certain packages, then we use this run command. Run command inside your Docker file, it runs a command during image build. It means that when you're building an image, you want to do some kind of a perform some kind of activity by installing certain package, right? Something like that. You can use this run command. And run is very important, guys. We will be using heavily the run command inside while writing a Docker file. You will see that I'll be using this run command, and I'll be installing some kind of a package, or I'll be doing some kind of an activity with the help of a run instruction, right? So guys, I'm theoretically explaining all these things, but definitely when you try to learn by doing it practically, you will understand a better way. Okay, so don't worry now, certain things you might not understand, that is perfectly fine, no problem. But in tomorrow's session or in today's evening session, when you try to see how we are building an image actually with the help of a Docker file, then you will see that I will be using all these instructions. And if time permits, we'll do it today now only. We'll see. Let's see now only like how to build an image. So that I'll take a small example so that you'll get a complete picture. And let me write some other things like I have something like CMD. Okay, this command executes one, what is it? When creating a container. Right. So it means that suppose when I'm running a container, some instruction has to get executed. That instructions will be executed with the help of a CMD instructions actually. Right. So whenever you are trying to run any kind of an image. So how do you run an image, guys? What is the command you use it? Use a Docker container run command, right? And specify the image name, right? Or the specify the image, right? This is the command which you run it. We use it for running a image actually as a container. So in that case, what happened inside this image, whichever you are running, that image has this CMD instruction within it. And whatever the command you are passing inside the CMD, right, or part of the CMD, that will get executed as part of whenever you are running the container. So right after build the whole image, I will try to run the image, right, as a container. Yes, when you try to run the image, what are the same instruction, what you are passing it, whatever you are passing it with inside your image, that instructions will get executed actually. We'll see, guys, how to use it. And of course, apart from the CMD, there is something as an entry point is also there, which is very important. I will also discuss about the entry point also. Entry point is also same as CMD. You can either use a CMD or entry point for executing any kind of a commands while creating a container. You can call either CMD or entry point. But what is the difference between entry point and CMD? Very soon we are going to see. We are going to look into it. And also it is very important for all of us to understand the difference between the CMD and entry point. When to use CMD, when to use entry point, we should have a clear cut understanding. Why? Because that this is very important in interview. They're going to confuse you by asking this question repeatedly many times. Why we use the CMD? Why not entry point? If can we use both the CMD and entry point in the same Docker file? If not, why we can't use both of the things? What is the difference, core difference between the CMD and the entry point? They will ask you multiple times the same question to confuse you. So when you are having a clear-cut understanding between what is the difference between CMD and entry point, and also if you have a clear-cut understanding about when to use the CMD, when to use as entry point, right? Then I think your concept will be clear. You will not get confused. So people will get confused only when they are lack in the in the practicals, or when they don't know the real essence of using this instruction. Then only people will get confused. If you have a clear cut understanding about where to use CMD, where to use entry point, can we use both, under which scenario we use both, all those pros and cons of CMD and entry point, when you are aware, when you are clear, and when we are used these commands, instruction, everything several times while writing a document, then I think your doubts will get cleared. Then I don't think that you will get any kind of a confusion for answering any such questions actually. So intro, what happened that purposely he want to confuse you, he will try to confuse a lot when it comes to CMD and entry point. But in our session, guys, we will be thoroughly discussing about what is the difference between entry point and CMD, when to use, when to not use, all such things we will discuss so that all your confusion will get go off. You will not have any kind of a confusion. Right. Apart from this entry point CMD, there are other instructions are there, guys, which will be using it add, or I can even use a copy also. So why we use this? They are used to copy files or directories inside the image, actually, into the image or into the image, I can say. Suppose you want to copy the HTML template files inside the image, or you want to copy some kind of a directory where that directory has some kind of a files or folder structure. Then we use this add command or cmd or the copy command. Basically, we use it actually. Okay, so we'll see that, guys, all these things like how to do it, and also I think there's something like expose also there. So expose basically this publishes the port on which your application will be accessed or is accessed. For example, for all your web application, right, you know that the port is 80 where the application will be hosted, right? So you can just explicitly call something like expose 80. Something if you want to, you are building a custom image where you are using a MySQL database inside the image, actually. I mean, you want to launch the MySQL, then in that case, you will just say expose 3306, right? That is a port number which your MySQL uses. So whenever an end user, he want to access your MySQL, right, he will be able to access it with the help of this port number 3306. So in a lot of time when we are writing a Docker file, we use this expose also instruction, guys, because we are explicitly exposing the particular port actually, where that application or the application or the data or the database, whatever it might, right, it can be accessed by an external user. That's the reason you expose that port number. And it is always best practice that you always use this expose command explicitly inside your Docker file so that you will get to know that, okay, which is the port where those applications can be accessed by using that particular port number. Is it fine, guys? So, guys, we'll stop it here. In today's session, evening session, we'll have one more session today evening, probably at around, I think, 8 o'clock, not before that, like 8 o'clock, 8 p.m. next session. Today evening we'll have, right? 100% guys, I will take at any cost, I will take because I don't have any work. I will take the class at 8 o'clock. 8 p.m. IST, I will take the class today, next session, where you are going to write the Docker file by using the instruction that instructions, and then build build the image, build the customized image with the Docker file. From the Docker file, run the container, and always also what, push the image into the hub.docker.com. This is something, guys, which we'll be learning in today's evening session. Am I clear? So we will be writing a lot of Docker files now from now onwards, and we'll be understanding about what are these instructions are there and how to build it. And also our main intention is to learn this Docker file very well, perfectly. This is what in interview they'll ask you, because in interview 200% what they'll do, that they will try to ask you to share your screen and they'll give you scenario and they will say that, okay, have you ever built a Docker file? You'll say yes. How many years of experience you have? You will say I have 5 or 6 years experience. Okay, can you write a Docker file for this requirement? So you need to start typing, you need to start writing a Docker file in front of them. So they will get to know about like how you are writing a Docker file, and also some kind of a cross question they will ask you when you're writing a Docker file. You should be able to answer for every question, whatever they ask, right? You should be able to answer it. After this, guys, once you start writing the Docker file, once you use a Docker file for creating an image, custom image, right? One more important topic which always comes to mind is like what kind of a security measure, what are the best practice you are following, best practice you are following for writing a Docker file, Docker file. That is first question. That's the first thing which they ask it. Second is that what are the security measures you are going to take it. Suppose if your Docker image having some kind of a vulnerability issues, is there any tool, is there tool which does secure scan of your image, of your customized image? Yes, there are various tools are there. Like for example, Dockley is one of the tool which you'll be learning. Trivy is one of the tool which you're using, right? Many other tools are there, guys. We will be learning about that. And the third important thing that after doing this, basically, okay, best practice for then you will be learning about something as a multi-stage, multi-stage Docker actually, Docker file. How to write a multi-stage Docker file? What is the advantage you're going to? What is a Docker multi-stage? That's what they're going to ask. And how to write a Docker multi-stage, right? And right, this is something which is important. And finally, what happened? How to create your own private registry. So this is what they will ask you guys. So this all the things whatever I'm saying, right? This is what the very important like when it comes to the entry point of view. You need to know all these things actually, all these things. So in the next 5 to 6 sessions, we will be learning only about this only. Am I clear, sir? So all our next classes, everything will be only lab exercise, only practicals, no theory, because we will be learning about all these instructions, run CMD label, right? All these things, and we'll be using all these instructions inside our Docker file. And how to write a Docker file in a very nice way, customized way. That is what we need to learn. That are the best practices. And then what are the security measures we take it, and finally how to write a multi-stage Docker file. And also like we'll also learn how to create your own private registry, how to push your images, the customized images into your private registry. That also we will be learning it. Clear, guys? Okay, with that, we'll stop today's session, guys. We'll meet at today evening at 8 o'clock, 8 p.m. I still will see it, where we will be learning a very basic understanding about how to write a Docker file and everything, right? Slowly in our upcoming session, we'll be learning all these other things also. Okay, okay, guys. So then, guys, are there any questions? Did you understood today's session? Okay.
Yes, yes, Rajesh, yeah.
Sure, guys. Okay, fine. So next 4 to 5 session, guys, it will be quite interesting for all of us because we'll be learning many things. Okay, fine, guys. Let us meet today at evening 8 p.m. IST. Okay. Thank you then.
Rajesh, uh,
Yes.
that mentioning the expose and the port number in the expose is not
Hmm.
enough, right? We have to uh, specifically mention the port number in the Docker run
Hmm.
command, right? While
Yes.
running the
There is
system.
something like a port mapping is there, which we will be learning that also. Yes. Port mapping have not come, even though we have used this port mapping several times in our previous classes, but I have not really explained what is port mapping. Let us even understand that port mapping also. Okay.
Yeah,
Fine, guys.
thanks, Rajesh.
Thank you then. Like meet at today evening. 8 o'clock at any cost. I will take class, guys. I will not miss it. Hmm? Thank you then. Let me stop the recording, guys.